Today, we're going to look at fracture orientation using 2D Mohr circle. Then I'm going to do a very quick example on 2D Mohr circle from Mohr element to Mohr circle to element. Then we're going to do a detailed example of optimization of carbon fiber reinforced plastic on fiber orientation. Okay. So those of you who are here, I've given you 3 chalks. Okay. Don't do anything with the chalks here. Okay. So the first thing, chalk number 1. Okay, so this is one of the chalk. We're going to induce a tensile loading. Okay, P and P prime. And on the tensile loading, we're going to label this X, Y, and this is our Z. So we are going to draw our element on the chalk, and we are going to label this as our surface X and our surface Y. Okay. So when that's the case, when we go into Mohr circle, right? This is our normal stress. This is our shearing stress, element rotating clockwise, element rotating anti-clockwise. And we know that for this case, over here, this represents stress X, and this will be our stress Y. And then we also know that we are going to label this as point X, and we're going to label this as point Y. Okay. So when we draw Mohr circle, this is how the structure is loaded based on 2D Mohr circle. Okay. So those of you who are here, we are going to do an experiment. Okay. And I want you all to focus on the board first. Okay. And also focus what we have over there. Okay. So on the board, so if you could do the same like me, okay, you have your chalk, and we are going to draw an element on the chalk. Okay, if you could. And then on this chalk, we are going to label the vertical surface as our point X and our horizontal surface as point Y. Exactly the same as on the board over there, yes or no? Okay, so can you do that? Okay, if you can do something to your chalk. Okay. And from here, we are going to pull our chalk with our fingers P, and over here is our P prime. Okay, so I'll show you what will happen, and you will do the same. Are we clear? Or do you all want to make a guess how will the cracked surface look like? Okay, no guessing, not sure. Okay, let's do it. Okay. Pull it. Can you see what happened? Yes or no? Vertically. If you do the same, yes or no? Right? typically. Okay. So what you see over here, you're finished already? Okay, hear me out. Okay, hear me out. This is point X, right? Over here, this is point X. This is point X, and this surface over here is what? Point X. So when we pull the chalk, this is our chalk, and this is our element, right? And we label this as point X. And when we pull it, what happened is the chalk fracture in tension. And this is our element, and we label this as point X. Okay. So where the chalk fail, okay, the orientation of the fracture surface is perpendicular, or is perpendicular to surface what? X. Yes or no? It's perpendicular to the surface X. And if you all do the same, of you get that or no? The test is common. Test is not what? Unique. The next test that we're going to do is this. The next test is going to do. The next test that we're going to do, okay, chalk number 2, is we are still going to have the chalk. So this is your right, and this is your left. Your right hand will curve forward, will twist forward. Your left hand, so the right hand will twist away from you. Okay. The left hand will twist towards you. So you are over here. Okay, so this is your eye. Okay, you are over here. We put in an element. Okay. So the element now will look like this. And this is how, right, the shearing stress will look like. This is our point X, and this will be our point what? Y. Okay. Now, if we were to put this on Mohr circle, this is our normal stress. Shearing stress, element rotate clockwise, element rotate anti-clockwise. At point X, the element will rotate where? You put your finger over here, the element will rotate anti-clockwise. So this is your point X. And over here, this is your point Y. Y will rotate clockwise. So when you draw this, you get a Mohr circle. Okay. And I'm going to call this stress 1. This is your stress 2. Okay. Now we know, what do we know? We know that chalk is what? Brittle, cannot withstand tensile loading. It cannot withstand tensile loading. Okay. So now, by using Mohr circle, right, how the surface fracture? Okay. Again, by using Mohr circle, how will the surface what? Fracture. Okay. So as I mentioned, this is what? Tensile. Over here, this is what? Compression. So from Mohr circle, from point X to tensile, it will rotate 90 degrees, what? Counterclockwise. Okay. So on the element, we are going to see a 45 degrees rotation in a what? Anti-clockwise direction. And this will be the orientation of our fracture surface. That is the orientation of our fracture surface. Is this true? Then we go back to the chalk again. Okay. You all don't do anything. You all see how I break. Then I want you all to see how you break. Okay. Again, if you have time on the chalk, chalk. Okay. Draw the element. And now when you draw the element, the arrow will go this way. So this is what we call positive what? Okay. And we are going to label this as X. Relative to X, we know, based on Mohr circle, we know that a fracture will be in this orientation. That orientation they have just drawn is from where? Mohr circle, over there. Okay, look at Mohr circle. So I'm going to break it now. And I want you to see the orientation. So it should orientate this way, okay? From surface X, I repeat again, from surface X is going to fail which way? That way, okay? So what I'm going to do is my right hand, okay? My right hand will twist away my left hand. Don't look at me, okay? You look at your own hand because we are opposite. My left hand will come towards me. Okay, so if you were to do yours, okay, look at the vertical arrow. Your right hand will twist away. Your left hand will twist towards you. Are we clear? So it's this direction. Are we clear? So I'm going to do that. You don't do anything. I'm going to do that now. Okay, I'm going to do that now. Okay, so I'm going to twist. And I want you to see the orientation. So if this is my what? If this vertical is my X, yes or no? It rotates by what? Anti-clockwise by 45 degrees. Can you see that? Right? The vertical is my what? X. Okay, then it rotates anti-clockwise. We projected that will happen. Yes or no? So if you look at the other chalk, right? At this surface, you can see that it fell by what? 45 degrees. Okay? Now, I want you to look at the board. That board now. Can someone tell me why from point X it will not rotate in the clockwise direction. It went what? Anti-clockwise. Why? Interesting, isn't it? This is